So this video just gives some practice problems that involve arithmetic and geometric sequences and series. They're kind of all mixed together. I think the first thing you should do is pause and somewhere on a side sheet of paper, remind yourself or write down some of the formulas for an arithmetic series and a geometric series. So I have them on the side of the paper, but that's what we'll be using. Okay, so the first one says, write an explicit formula for the sequence. And if you look, I keep subtracting 7, right? Mere sequence is just a bunch of numbers in some kind of pattern. And if you're continuously adding or subtracting, that's, of course, arithmetic. So the nth term would be the first term times the common difference, which is -7 times n minus 1. Well, it's really plus the common difference, but we're adding a negative, so it'd be -7 times n minus 1. So, of course, if I kind of simplify that, what do I get? I get 37 minus 7n plus 7, so it would simplify to 44 minus 7n. That would be the explicit formula or the nth term of that arithmetic sequence. Now, if you want to write that recursively, remember how recursive works. You got to give it a starting point. So we start at 37. And then to get any given term, I'm going to take the term before it, and I'm going to subtract 7. That's it. So recursive formula has kind of a base step, and then it has a rule. There's really two parts to it. Okay, if I wanted to get the 100th term, take the formula for the nth term, except now we'll plug in n equals 100. So it'll be 44 minus 7 times 100. So that gives you -656. Certainly much easier to use the formula than it is to, write out all 100 terms. And then finally, S sub 100 means add up the first 100 terms. There's a couple ways. I'm going to use this kind of the second formula for arithmetic sums. Both of them look fairly familiar, but it's the first term, and then you double the first term. So I'm going to double 37, and I'm going to subtract the common difference, n minus 1 times. That's 99 times. And I'm going to divide all that by 2. So if you add up the first 100 terms, you get -30,950. There we go. All right, so if we look at the next one, goes with 5, 6, and 7. There's my first typo of the day. Look at what you got there. You got to try to look at the pattern, and it looks like you keep multiplying by -1/2, so that's geometric, right? That's half the battle, is figuring out what kind of sequence you have. So if you want an explicit formula, which just means writing out the nth term, it's the first term times the common ratio to the n minus first power. Again, I'm getting those formulas that I wrote down at the very beginning of the worksheet. Recursively, give it a starting spot. Well, we start at 200. How do we get the nth term? We take the one right before it. That's a sub n minus 1. And we multiply that by -1/2. So I'd probably write this as -1/2 times a sub n minus 1. There it is. And if I want to add up the first 12 terms, again, it wouldn't take you long to just write out all 12 and add them up, but so let's do it. We start at 200. That's our first term. It's 1 minus the common ratio, which is -1/2 to the 12th. And then we're going to divide by 1 minus a minus 1/2. Again, if you're going to put all this in your calculator, you got to group the top and the bottom together. If you put this in your calculator, you get about 133.3. Okay. moving on to the back. And I'm moving fairly quickly here, but I realize you can certainly hit the pause button. Okay, number 8. It's only 5 terms. Let's just write them all out, right? The indexing variable goes from 1 to 5, right? So you're just plugging in 1, 2, 3, 4, and 5. So, you know, if you 2 to the first minus 1 is just 1. 2 squared is 4, minus 1 is 3. 2 cubed is 8, minus 1 is 7. So what do you got? All the powers of 2, but you subtract 1 and then add them up. You get 57. By the way, that's neither arithmetic or geometric. It's got no special name to that. This next one here, you're repeatedly multiplying by 4/5, so that's geometric. Okay, and your first term here, if you look at it, is 40, right? Because if you plug in 1, you're going to get 40. That's really all you need, because the first 20 terms, when you add them up, it's the first term 1 minus the common ratio to the 20th power over 1 minus the common ratio, 1 minus 4/5. Again, on the calculator, you got to group the top and the bottom and hit the divide key in between. And so for number 9, this shakes out about 197.69. Okay. All right, couple more here. This one's going to be arithmetic. You could tell because the argument here is linear, and you're just subtracting 6 every time. The first term, when you plug in 1, you're going to get 207. Of course, there's 42 terms. So let's see what we can do here, right? The sum of the first 42 terms is n, right? I got to double the first term. The common ratio is minus 6, so it's minus 6 times n minus 1, which is 41. And you divide the whole thing by 2. The sum of the first 42 terms, 3528. All right. And we got one more here. This is also arithmetic because this is linear, right? The common difference is 2. Now be careful. The first term is actually, this is tricky. You know, really the first term, because your index starts at 0. So your first term is actually 8, right? And the number of terms is actually 31. So let's see if we can get this right, right? The sum of your first 31 terms is what? The number of terms, which is 31. And then what am I going to do? I'm going to double the first term, which is 8. Actually, what am I talking about? The first term is 6. Guys, I apologize. If you plug in 0 for the first term, it's 6, right? So double the first term. And the common difference is also 2. And n minus 1 would be 30. Right, I group that together and I divide this whole thing by 2. And if I put that in the calculator, I should get 1116. Okay. Finally, just a couple of word problems to end it here. Right. If you see this guy's given his son 95% of what he did the day before. So that's geometric because you're really multiplying the day before by 0.95. The last day of school, so school day 180, how much will he contribute on the last day of school? So that's the 180th term of a sequence that starts at 1,000 and gives 95%, and the power n minus 1 would be 179. So by then, it shakes out, he gets about 10 cents on the last day of school. Kid got 1,000 the first day, but then you keep taking 95%, eventually you're down to almost nothing. Now, totally, you know, it's 1,000 plus 950 plus 95% of 950 plus 95% of that number. That's the sum of the first 180 terms. And again, you start the first term, it's 1 minus r, which is 95% to the 180th power over 1 minus 0.95. The calculator, this kid gets a pretty hefty allowance, $19,998.04. And finally they ask, hey, when is this, on what school day will his contribution dip below $50? So I want to know when that nth term, right, here's the formula for the nth term, when does it finally hit $50? Of course, we want to solve this, so we got to divide both sides by 1,000. So I got 0.95 to the n minus 1. If I divide by 1,000, I get 0.05. And guess what? We have an exponential. I got to get rid of it. This goes back a little ways. Got to log both sides. That allows this power to come in front. And finally, I get, I'm rewriting this n minus 1 times the log of 0.95 is equal to the log of 0.05, right? I would have to do what? Divide by log of 0.95 and add 1. So n would be log of 0.05 divided by the log of 0.95. Oops, 0.95 plus 1, which would be n here would be about 59.4. So finally, by day 60, his contribution dips below $50. Okay, I hope that was helpful. Just some review.